I would like to take you through how you can create graphs in SPSS. So in order to do this, we shall be using an example dataset which have been provided by SPSS. So we can all of us be in that dataset for uniformity and so that you can be able to follow this video very easily. So let us open the dataset. So it will just take some minute to open this dataset and we'll be in the SPSS interface. So it will just take some minutes or some seconds based on the speed of your computer. So that right now our data is already loaded in SPSS. You can see the command which it have run to give us this data. This is the command which have been input in order to give us these data in SPSS. This is the path which these data have been uploaded in SPSS using. So we can get back into our dataset. So when we get back into the dataset, you can notice we have two windows. We have the data view window and the variable view window. So as you can see in the variable view window, you can be able to see various variables making up our datasets, and you can be able to notice what every variable represents using the label so that you can be able to interpret your graph history. Then you have the data view window. This is where you can be able to visualize the dataset, the various data contained in different variables in the dataset which you have. So you can be able even to notice if you have availability of missing variables in your dataset so that you don't make absurd reporting or graphs which do not make any sense. So even if you want to notice if your data is good for making analysis, it's usually good before you start drawing any graph or doing any analysis in SPSS to just come to where we have analyze, and then come to where we have missing values analysis. You can use all the variables, and then you can click OK. So a univariate statistic tabular will be generated here. So you can see the percentage of missing variables is too low in this data. So this means that this data is not biased, despite where we had internet, where we had a missing value of 4%, which is technically below the set threshold of 5%. So this data tells us this data is good for doing our analysis. So what are we supposed to do? We are now supposed to get back into our dataset and start the activity which brought us here. So we need to generate graph in SPSS. So what we need to do, we need to come to where we have graphs. But I want to show you some trick here. In case you don't know the kind of graph which you can generate for a certain variable, you can come to where we have graph board template chooser. So this is a sophisticated option in SPSS, which technically helps you to click over a variable and then SPSS predicts the type of graph which you need to draw based on the type of the variable. Maybe here we have a continuous variable like years. So years, they are continuous in nature. So the best graph which we can generate a histogram with a normal distribution and see the distribution of our years and notice if our years are normally distributed or they are skewed in nature. So technically, we can try and generate a histogram of distribution of the years and then click OK. So an output will be produced here below. Let me show you. So this is the output which we have received, giving us an analysis of the age. You can notice, despite the graph having a kurtosis, which are at the left, since we have a tail in the left where we didn't have data, since this data was collected from adults who are allowed 18 years to henceforth to around 80 years. So you can notice in this surface area, we didn't have any data. That's why we are having a kurtosis or a long tail, which is not covering any data. So as you can see, this is how this chart, how do we call it? The graph board builder template help us to choose the best graphs based on the variable which we have. So we can move to another variable, maybe. Let me show you. We can move to another variable such as the primary car vehicle category. So you can notice the primary car vehicle category, it have been arranged in a way which it is a nominal in nature, it's a nominal variable in nature, but the measure which we can use is ordinal, since every car which you have, you derive some utility from that car. We can try and generate a pie chart and see how the primary vehicle price category is analyzed using SPSS, using the pie chart. Let us see. So you can see we have some different car here. We have the economy car for the ordinary person. We have the standard class, which we can say is for the middle class. And then for people who are living the dream, we have the luxury car. But it seems like we had a lot of luxury car more than the economy and standard cars. So this means this is a developed economy. So this is how we can be able to generate graphs using the graph board choose a template, which allows us and give us and which tells us the best graph we can generate for a certain data set. But now that was not our main goal. We can close the window, this output window, and now start drawing graphs with the option which is recommended in SPSS, which is the best actually. So in order to generate graphs in SPSS, we need to come to where we have graphs, then come to where we have legacy dialog. So we can generate different type of graphs, but we shall focus on the major one. So we can generate a bar chart, we can generate a 3D bar, then we can generate the line chart, then the area graph, the pie chart, the high row, the box plot, the error bar, the population pyramid, the scatter plot, and a histogram. So we shall technically generate all of them, but for interpretation, some of them will avoid interpretation since they are so complicated to interpret some graphs. So some of them need some level of research, but we shall generate the major graphs which we usually use. So first thing first, we shall start with a bar chart. So in order to generate a bar chart, we need to come to where we have graphs. Then we need to come to where we have legacy dialog. Then we select a bar chart. So we can technically, for in this case, generate just a simple bar chart and then click define. So when we click define, I usually recommend we use bars representing other statistics, e.g. mean. So we can select a variable which we need to generate a bar chart for. Maybe we can select the variable age, and then we can select age and compare the age with the gender category. We use the gender as category, then click OK. So you can notice a very slight difference between the female, who seems to be around 43 years old, and then the male, who are slightly above them. So, but it is not representing it very well. So we can try and compare another variable. Maybe we can come here where we have charts and then generate a bar graph comparing. We can select a simple bar chart. Then we can try and compare the variable income. Where is the household income? And the household income and the level of education of an individual. Then this can generate a somehow bar chart which makes some sense. So you can notice that when we try to compare the household income and the level of education, you can notice this seems to be a biased data, since you can notice that the people who did not complete school, they technically seem to earn lower than those with high school degree, and those with high school degree earn lower than those with some college degrees, and those with a college degree. So you can notice the level of education is increasing. That is how the income of an individual seems to be increasing, which is technically not always the case. But this is how we can come up with a simple bar chart in SPSS. You can try using the other variables in our dataset and come up with a different bar chart. So let us continue, and then we can come up with the now 3D bar chart in SPSS. So to come up with a 3D bar chart, so we can select the group of the cases. We can group the cases and click define. So to group the cases, we can select the variable to be our household, the household income. Let me select the mean. Let us use the mean. So we can select the variable being the household income. Then the category variable, we can select the level of education. Then the Z category, we can select maybe the retirement. Then we can choose to run the data. So you can see this 3D model trying to compare the household income in thousand, the level of education, and the retirement. Though a lot of people may not be able to interpret this graph, but it's so simple to interpret. It's a 3D graph which is comparing. So we have these y-axis, we have the x-axis, and we have the z-axis. So you can use these axes to compare the level of education, the household, and the retirement at the same time or simultaneously. So let us continue. So we can continue and now do the third graph. Under the legacy dialog, we can generate a line graph. So we can just choose a simple line chart, which is here. Then click define. So we can choose to define this line graph using other statistics like mean. So the first variable which we can select household income as our variable. I like more dealing with income. Then we can select the level of education. Then click OK and see the line chart. So you can notice, despite here we have a trap here where the graph seems to go down as you continue to run, then it is straightened again. You can notice the positive relation or positive correlation between the household income and the level of education of an individual. So they are directly correlated or directly proportional. So it can be visualized by this straight line, which is running from left to right. That is how it is telling us that the more educated you are, the more probable you are earning more income as compared to the people who did not attend the school. This is why they are trying to tell us. What I disagree, but I don't know if your case you agree with these data. Then we can continue to generate another graph. So there are a lot of graphs here. So we can try and come up with an area graph. So we need to come here. We shall just generate a simple area graph. But when you are doing your exercise, you can try and work with the stacked area graph. And in case you get any problem, you can just contact me and we can deal with it. So we shall just click simple, then click define. Then what you're supposed to do, you are supposed to come here and select, we shall be dealing in this case with the household income and the level of education, and generate a certain area and see how it will give us the output. So we shall just select, we shall just choose the area to represent. We need the area to represent our income. Then we click OK. Then we select the category. The category is the level of education. Then we enter. Then we click OK. So as you can see, it just depicts the same case despite putting it in an area. You can see it just simply show the same case. You can notice a trajectory which is positive correlated despite being a block. So I didn't draw the graph. So in order to make it more sensible, we can try and generate the area graph again. What we do, we shall just generate a stacked. So this it's somehow stacked. We show how it will generate this model. It is so beautiful graphs. And then what we do, we can just select other statistics. We can then come here, select the variable again as the income. Then select the category as we can select our category as the level of education. Then we can try and maybe define area by. We can try and define the area with job satisfaction. Then click OK. Let's see the. Can you see? So the people who are highly dissatisfied is where you see these blue line. Somehow satisfied, you can see these. So they are, to make the matter worse, There are people who are earning a lot of income, and you can notice they are not satisfied. So what does this tells you? The people, this is a very informative statistics. It tells you you can be earning a lot of income, but you don't feel satisfied. You can notice there are people who are very satisfied despite having the lowest level of income and technically being not educated. In some cases they are not educated. So this is how we can be able to generate area graphs in using SPSS. This is a very beautiful graph to generate, though some people say that SPSS does not generate beautiful graphs. You need to interact with the software and come up with more sophisticated graphs, and you can notice how SPSS is powerful in case you are able to utilize it well. Then we can move to the next graph for a matter of time and to save time. You can interact with the area graphs and try to generate as more area graphs as possible. We can generate some pie charts. So for pie charts, we can just select summary of the group and then click define. Then we can try and generate. You can try and use some of the variables. And then you can select the household income as the variable. You can try and slice this household income with the maybe we say level of education. I like using the level of education as the normal case, since this is usually a question of discussion. Then click OK. So you can notice the level of education maybe did not complete high school and the income which they get. So you can see income by the level of education did not complete school. This is their income. So high school degree, this is the level of the income which is allocated to them. Then some college, this is the level of income allocated to them. Post college is here, but a lot of people seem to drop here where we had high school degree and where we have what is this, the college degree. But where we have postgraduate, they earn a lot of income, but the circle is so small. So that's this data is also so informative. It's trying to tell us the more the people are earning is how the circle of the people in that class, they are very low. As you can notice, the people with post-undergraduate degree, they are very few, but the income which they are earning, it is very high. But you cannot be able to visualize this using the pie chart. We are just tracing it using the level of education and try and visualize where the income is, a lot of income is moving, which it can be important when making aggregate decision. From there, we can continue with graphs. So we have a lot of graphs here. We have the high-row method. So we can just use the simple high-row case. Then click define. Then we can select bar to represent. Maybe the high bar to represent the household income, and the lower bar can represent maybe the age. Let's see how it will generate this one, and we can change statistics. Okay, let us remain like that. Then the cross can be the level of education. Then the category axis, we can have the gender. I want to do something here and see how it will produce this one. So as you can see, we have household income in age, household income in thousand, age in years, and the level of education. So we can be able to get these. So in the x-axis, we have the gender, which is categorizing, and in the y-axis, we technically have the income and the years. So it is well represented by by this bar. And then where we have the level of education, you can see the level of education is technically seems to be the same. It is in the same line. It's represented by these level dots. So we can continue to generate other graphs and generate a box plot, or what we refer to as a box and whisker plot. So we can just click define. Then what you're supposed to do, you can generate the variable household income, which is here. Let me take the household income to be a variable, and the category axis, we can take category axis as the level of education. Then we can learn this data set and generate a box and whisker plot. So you can see, so it is so populated, so but you can be able to visualize something. As we continue, you can be able to notice the lower part of the dot and whisker plot. So it is called a whisker plot since it represents the shape of a glass of whiskey. For people who are drunkards, you can be able to correlate with the dot and whisker plot. So as you can see, it seems like the people who did not complete high school, their incomes try to be more populated in the margin below 600,000. This is where the data is populated. As you go much, you can notice the income continue increasing as up to where now we get to the postgraduate. Though there are not a lot of data in the postgraduate, but you can notice we have the highest income level where we have postgraduate, where you can see 250 here. So the income continue rising up when you move close to the highest level of education. But don't get worried. These are just technically demonstrating the different graphs which you can create. In case you need to do more interpretation, you can ask your query. But I wanted us to counter check all these graphs and see how they look like. So we have the error bar. So we can just go to is the graph for how many times? So we have 1, 2, 3, 4, 5, 6, 7. So it is our 7th graph, the error bar chart. So we can just create the simple one. So there is nothing bad with dealing with the simple. There is no bravado in hitting yourself down to the wall. So what you need to do, you can select the household income here as the variable, and you can categorize this household income with the basically level of education. I just doing this analysis. We shall be assuming a confidence interval, a level of 95%. Then we can click OK. So as you can see, this you can interpret it as the different utility which you have. So you can notice these bars, they continue rising as you go to this side, and their size continue adjusting. So you can notice like this bar here is technically somehow equal to this. As you can notice, when we drew a pie chart, these bars seems to be, the size of the pie chart seems to be the same for this bar and this bar. For those who did not complete their high school education, and those who are in high school education income seem to be the same. Then you can notice as you move up to the ladder, the error continue increasing, or the size of the bar continue increasing. So we can continue and come to the population pyramid graph. So we can be able even to generate population pyramid when in SPSS and generate some pyramid which can try to explain some level of our data. So we shall also generate a population pyramid just using the household income again. So let me choose to get count from variable. So we can select the household income, and then we can decide to sprint it over the level of education. And then we can show the distribution over the level of education, and we can try to sprint it with the retirement. Then we can click OK. So this pyramid is not clear, though it gives some information, but to interpret it is somehow complicated. So let me try and generate another pyramid using different data set. This is not the best. Let's try and do the best and try and see if we can generate the best pyramid out of this. So we can come to where we have graph. We come to the legacy dialog, the population pyramid. So we can remove the retired, and then instead of the retired, we can choose the household income, the level of education, and the primary vehicle. The primary vehicle, let me input it here. Then try and slice it and see. It is giving us the same pyramid. Let me do it again and try and see if we can generate something which technically resembles the pyramid. So we can remove this and try and deal with Marito status and see. Okay. So it's just giving us the same structure of the pyramid, which is also easy to interpret, but I wanted to generate a more sophisticated pyramid. But in case you want to do that, we are just generating the simple one. So what we can do, we can come to where we have pyramid. Let me remove it and then come to where we have graphs, come to the legacy dialog, then come to where we have pyramids. And I'll create a video showing you how you can come with a pyramid which resembles technically the rig pyramid, and it analyzes the data set using some graphical interpretation which are easier to interpret rather than these ones. So we can come here and now go to our technically the second last graph which you can generate, which is one of the most popular, the scatter and the dot plot. So we can just do the simple scatter plot, then click define. So we can generate a scatter plot where the y-axis represents the household income. So the y-axis is our dependent variable, where the x-axis, which is the dependent variable, is the age, and compare how the income varies as the age change. Then click OK. Let's go downward. So there is some level of is it a positive relation between the age and the income, but we can try and see if we can be able to come up with a line of the best fit from here. Add a reference line. Let me see if I can be able to come up with the line of the best fit. Let me cross here. Let me come here and generate the line of the best fit. Add the line of the best fit. So as we create a line of the best fit, you can notice. Let me first across this window. So you can notice. So the line of the best fit is here. Let me show you. Is here. So when we fit a line, so you can notice this line is giving us the equation which is here, which is y is equals to the constant, which is 20.83 plus 2.15x. So you can notice a positive correlation between the household income and the age. So we can continue for the matter of time and for the benefit of time. Then we can create another graph, which is also so important. That is the great histogram. These are the graphs which I love for statistics. They are so informative. So we can create a histogram, maybe seeing how our income was distributed. Then we can take our income here and take it as a variable here. Then we can click OK. So you can see as our histogram shows, our income is here. So you can notice a lot of income ranges. Not a lot of our income is around. It's just a lower income is around 100. That is 100,000. Then as you continue down to the rounder, you can notice the margin reduce of the frequency. Frequency is how frequent that income is being paid. The frequency reduce. As you can see, the mean income is around 69,000. The standard deviation is around 78, and the number of observation is 6,800. So we can see how the income is distributed. So to see how the income is distributed, maybe we can use let me not use this method. So we can get back to the graph and then come to where we have the histogram. Then we can select to show a normal curve and then click OK. So another histogram will be generated here. But you can notice our income is skewed to the right. So we have a lot of outliers. That is the meaning of the people who are earning a lot of income, a certain small percentage. But the larger percentage is the one which is earning the income below 200,000. So this is how we usually interpret it. So this is where now we are experiencing some skewness. And from here to here, you can notice some kurtosis. That is the tailness of the graph. So it is covering the tailness is covering the space which does not have data. So this is how we can generate various graphs in SPSS which are provided by SPSS and try and interpret them as simple as possible. So some of them, they are sometimes hectic to interpret based on the data which you have. But in case you get a problem interpreting any data set in SPSS, you can get in touch with me. So my contact is always under the description of any video. So in case you are through with this data and doing this analysis, you can save this output for later reference. So all this output, you can be able to save it. So you can save this output. So also you can be able to save this output as a syntax file, as syntax. So, and to be able to save this output as syntax file, what you can do, instead of now clicking OK, you can just click paste. And when you paste, all this, you can repeat by all the procedure by pasting, and then command will be generated here. And to play the command, you just need to hit play, and the data will be generated, and then you can save the data set as a syntax file.